Where's Tori? There he is. Good. Anybody want to put up the work?
I would if I knew how to do it. I said if I knew how to do it.
Yeah, you're gonna learn how to do it. Can you tell me, like, from your point of dilation to the vertex, how much, like, what's the slope? How much you have to?
2 and 1.
Good. How many times are you gonna do that?
3 times.
Then from here.
So there's 3 times. 3.
But do it 3 times.
1, 2. Oh.
And then plot that. And you're gonna repeat that process for all the points. So you'd repeat it again for B. So it would be like up 3 over 1.
Wait, so do one, so I could see like an example.
Sure. So the slope is like up 3 over 1.
Uh-huh.
So I'm gonna do that how many times?
3 times.
So once, twice, 3 times. And then when you get all the points, you'll like connect them. Try it, let's see. Yeah.
Will I always go to the first one?
It doesn't matter. I would get in the habit of doing rise first. Just because when you write out your slope, rise comes first. So
Hell no.
So you see from here, right? You have to do it 3 times. So 1, 2, and it goes up 1.
Where would it end up?
So it's 2 over 1. You have to do it 3 times.
Where would it end up?
Like somewhere around
Oh,
here.
so 1, so 2, like that, and then like that. Oh, and then look, wait. Look. No, one more question. Do you start from here, like 1, 2, 3 times from here?
Yeah, you start from there, doing it 3 times.
1, 2, 1. 1, 2, 1. Wait, but I can only do it. Will end up here. I'll only do it 2 times.
I care less about you filling in that slope stuff. I care more about you doing that dilation.
And then you do the same
The
thing.
method that we learned the other day.
1, 2, 1, 2. Would it be like this? 1, and then 1, 2, 3. Or would it be like that? Would it be like that? Or would it be like that or like that?
He said it went bad.
Okay, so 1, 2, 3. 1, 1, 2, 3. 1, 1, 2. I think it will end up right here, right? Like at the top, right here.
Make sure you got primes on there. That looks good. That looks real good.
And then do the line, right?
You good?
And then connect them. Right?
Yeah.
You took me to me? What you said? Oh, I thought you said it's cool. This man is sloppy. Oh, and then I gotta do all these. So that would be 2 over 1, right? For this. For the slope. 2 over 1. Because 1, 2. Or 1 over 2.
Yeah, 1 over 2. 1 over negative.
Is it with this negative?
Yeah.
Over years.
See negative 2 right here, and then 1. It went up 1 time, but it's on flat. The A is on negative 2. I get it.
Yeah, perfect. Thank you, Alexa. I thought you said you didn't know how to do this.
Well, when I put my mind to something.
Agreed, Alexis. All right. I'm going to be fully transparent. A lot of today's lesson is going to depend on our understanding of the launch.
I'm so smart.
All right. If you get the launch, today's lesson isn't that bad. So with that said, let's go through it. What is the question asking us to do?
Scale factor of 3.
Well, what transformation uses?
Do it 3 times. Multiplication.
Okay. So we're doing a dilation.
Okay.
Whenever you have a dilation, the important things are, what is one of the important things? Yeah, a scale factor of 3.
What? I did not say that.
Yeah, well, you said it earlier. And then what else? What else is important?
About the origin.
Yeah, about the origin. So when you do the dilation, you need to get in your head, how much am I dilating? And then where am I starting? Because Diana's pointing out the next thing. We're going to be looking at slope. We're going to get there next. Based on what we figured out, is this going to get bigger or smaller?
Bigger.
Why bigger? That's perfect. It's a whole number that's bigger than 1. All right. Out of curiosity, how many times bigger is it getting? 3 what? 3 times. So what operation is dilation? Multiplication. All right, multiplication. Well, wait. What is getting 3 times bigger? Okay, I agree. The sides are getting 3 times bigger. Yeah, the sides, the angles are staying the same. Dilations preserve angles. That's why the shape is going to stay the same. But yesterday we made a distinction, right? Yeah, I agree. The sides are getting 3 times bigger. But what's really getting multiplied by 3 times? What are you doing 3 times? The slope. That is to say, the distance from your point of dilation to a vertex. That is the thing that's going to get multiplied. That is the thing that you're going to repeat. So, what is the slope from O to A?
O to A is 2. Wait, what? Never mind.
Put it in terms of rise and run.
1 over negative 2.
Yes, that is correct. That is a rise of 1, so you're going to go up 1, and then to the left 2. We're going to talk about Jacilia's signage on that slope, but right now we're just going to review. So how many times am I going to do that slope? You are doing it 3 times in total. So that's once, twice, 3 times. That's why A prime, Alexis, awesome job on the prime notation. A prime lands there. Okay? You just repeat that for all of them. Okay? So that's, if you can do that, that's a review of yesterday. We're going to turn our attention to these slopes. And hopefully you'll see why at the end of it. Where is this slope coming from? Why is it +1 and a -2? Yeah, so from the origin to the vertex, are we going up or down? So from the origin, from our point of dilation to the vertex, are we going up or down? So is that positive or negative? So leave that as a positive. And then are we going left or right? So that's a -2. Is everybody good on where that slope's coming from? Okay. That was that's our original. That's our original slope. What's the new slope? What's the new slope from the point of dilation to A prime? It is positive 3 over. Where did that come from? How did we get that? Well, what got multiplied by 3? So it's just the slope times 3?
Yes, sir.
Well, what does a slope have?
It has a rise and a run.
So did just the rise get multiplied by 3?
It's the whole thing. The rise and the run.
Gets multiplied.
By 3.
So your rise is going to get multiplied by 3. And your run is going to get multiplied by... Where did the 3 come from? Scale factor. That's why it's so important to get it in your head. So this is a quick review. Positive 3 comes from the top times the top. Positive 1 times a positive 3 equals positive 3. Negative 2 times that positive 3.
Good morning, Rocklighters. We have a few
Negative.
quick reminders for you today. First,
Good.
auditions for the VAL talent show are today after school. Middle schoolers should report to Miss Love's room after 8th period and high schoolers after 9th. A
Can
reminder
you,
that
while this is going on, you
today,
tell me the new
4
slope.
in room 126.
Use this method to
Seniors,
tell me what the
reminder that
new
seniors'
slope would be.
superlatives are due Friday, November 16th, so make sure to get your green papers into Ms. Sweeney or any student government representatives. A few reminders from student
You said
government.
3 cents,
First,
right?
the canned food drive is
-6,
happening in
but,
third period
like-
classes. And the third period
So,
classes
wooden rise, 1, 2, 3, 1, 2, 3, 4, 5, 6.
Yes, please just have a corner of your room for the cans to be stacked. A reminder that gratitude grams are being sold, so please get in the spirit and tell someone how much you're grateful for them. Small as $1, large as $3.
Okay.
Tuesday.
Yeah.
The SAT word of the day today is galvanizing. Adjectives that mean thrilling, exciting, and stimulating. For example,
Are you talking about that?
performance left everyone
Well,
stunned.
The new
this one is from here, you're going to go up 3, 1, 2, 3, and then you're going to run negative 6. 1, 2, 3, 4, 5. This one would be different. What's happening to the 3? By how much?
3.
So then it would go from 3 to... Perfect, write it down. And instead of negative 1, it's going to be... No, it's getting multiplied by what? Yeah, so it becomes... What's 1 times negative 3? Yeah, it becomes negative 3. So you're going to rise 9 and run negative 3. So what's our new slope? Positive or negative? So what this means, and this is literally today's lesson, right? This other method of like looking at slope, using your scale factor with multiplication, and then creating a dilated slope. That's what we're doing today. Guys, to get your slope, so like once we get that new slope, you're gonna take that and you're gonna start from the point of dilation. From the point of dilation, you're gonna go that new slope. You're gonna rise 1, 2, 3, and then you're gonna run negative 6. 1, 2, 3, 4, 5, 6. That's how we're going to get A prime. The new slope for B, you take the old slope, instead of going up 3 and over 1, right? You multiplied it out, you figured out the new slope was up 9 over negative 3. So we're going to go up 9 and then over negative 3. That's how we're getting there. That's the method we're going to practice today. And the reason why we're practicing it today is our objectives. We want to dilate about any point, not just the origin. The origin's easy. We're going to do this for any point. Our method will work for any point. And then we also want to be able to use strange scale factors. like 3/2 and 2/3 and maybe 1/5 and 7/8. Right? This method will guarantee you get that all good. Any questions on like what our goal is today? What are we doing today? What are we learning?
Math.
What kind of math are we learning today?
Geometry.
And which transformation?
Dilation.
Dilation. In order to do a dilation, what do you need? What do you need? What in this problem? So let's flip it over. Yeah, I think that's a really good way to put it. We're like simplifying our method. We're gonna take some notes. Other side. We're gonna take some notes so we got notes to look back on. So can you read it out for us, Tyler?
Dilate triangle ABC by
How much time can you give me to get through the notes? 7 minutes? Can you give me your attention for 7 minutes? And then we're just going to practice? Yeah? We can agree to that? All right. So, can I get a little quiet? All right, 7 minutes, and then we're just going to practice. For me to get through my lesson. That's all I got. So be on my team until then. So what's important when you read that? What's the stuff that's jumping out at you? And what else? Yeah. Point D. Those are the things you need for a dilation. So we need to make sure our figure is graphed. And what else needs to be in that graph? The point of dilation. That is super important. So we're immediately going to graph that. And you start at the origin, and it's over 3, up 1. This is the point of dilation. All right, that is where we're starting. So we need to find the slope. Where are we finding slope? Where do we start? Yeah, but where are we doing the rise? Yeah, we're doing it from the point, 3, 1. So we're going to start here, and then where are we going to? But
So that's basically like
yeah, that's a great way to put it. That's like, yeah, because that's where we're going to start, and then Tyler's telling us go to A. So we're going to find the slope from the point of dilation, what Jacili is saying is the origin, to a point on the figure. In other words, a vertex. And that's what Tyler's telling us. Oh, you're killing me. So then, how do we go from the point of dilation
2 point what?
to the point on the figure? Yeah, I like on better. There's too many froms in there. So what is that slope? What is the slope from D to A? Positive 1? Yeah, so it's down 1 and then to the left 1. That's why it's negative over a negative. Well, that's what we're going to skip. We're not going to do the repetition method because what we're preparing for is weird slopes like 1/3. We're going to do the multiplication method. So how are we going to take our original slope and create the new one? Why 2? Yeah, we're going to take our scale factor and multiply it by the top and the bottom. So that's literally the third step. Multiply the slope, that is the rise and the run, by our scale factor. So what will we get for our new slope? Yeah, -2 over -2. And then, starting from where? Where are we going to do this new slope? Perfect. And that's the most important thing. From the point of dilation, you're going to do that new slope. So instead of going down one and to the left one, now how much are we doing? Anna, how much are we doing? That would be our new one. So we're going to go down 2 to the left 2. And then what would I call that point? A prime, A prime. And then last is just you repeat it. Repeat it for all the points on the figure. Go ahead. Finish.
What's the new point of A?
I don't know. Whatever that is.
-1.
Yep. No, because it's
1 -1.
yeah, 1 comma -1. You are going to do that same method, but you're going to do it for like point B and C. So I'll give you like placeholders where you can fill that in. Can someone tell us what we're doing in the 2 minutes that I'm going to give you? What are we doing, Diana? What do you think we're going to do? Yeah, we're going to solve it, but how? What points are left?
Oh, C and B.
Perfect. Yeah, you're going to repeat this process for C and B. You're going to graph B prime, you're going to graph C prime. Take the 2 minutes that are left. Yeah? Who are you allowed to work with? Yeah. They beat you to it, Alistair. That's what so what's like your
Want help? Do you know how to start?
close. It's the rod.
That was like an example. Okay. So now, is this going to get bigger or smaller?
Now are you going this way or that?
It's going to get yeah. How do you know that?
I'll let you process.
Because it's going to fraction.
You're going to multiply
So
this by the scale factor.
this is going to get smaller. We're dilating it. And we're going to dilate it from this. Right? All the way.
What's it going to get multiplied? Where are these?
This is point D, right?
Where did that come from? It's good luck.
I gotta be so smart. Perfect. I gotta do it slow, step by step. You're like light years ahead of me. Huh?
But now it's going to be 2 times
Keep
1.
going, alright? You know what to do. You know what to do. Okay. Okay, so first off, it's gonna get dilated, right? It's gonna get bigger or smaller. It's gonna get bigger or smaller. How do you know it's gonna
So now, from the dilation, you're not going to go up 1 and over. Up 2 and then over how much? That is where. Let me see. That's. If you need help, ask your push-ups. So now, from the point of elevation, instead of going up one, start by finding the where's your point of dilation? Yeah, you're right. Use a all right, let's bring it back. On a fist of 5. 5 being like, yo, this is light work. 0 being, I know nothing. I don't even know what today is. How do you feel about this problem?
It got harder like as we started.
Yeah, agreed. Can I get a? How do you feel about that? Yeah, you look good on that. Yeah. Can you move on to the next one? I'm gonna open up the floor to a couple questions. Do people have questions? Where would B prime go? How would we do this? Can someone do it? Well, it's definitely multiplying. You gonna do it and explain it? You gonna do it? Maybe I'll talk it out.
Okay, what am I
So
doing?
what's your YouTube channel? I be wanting to watch it. I want to hear myself
Teacher live.
teaching.
So, Jacilia's recording the slope from the point of dilation to a vertex. You go up 1 and to the left 3, so it's positive 1 and a negative 3. She's multiplying the rise by 2 and the run by 2, because that's our scale factor. Top times top, 1 times 2 is 2. That's our new rise. And then negative 3 times 2, our scale factor. That's our new run. You're going to get a negative 6. Damn. So now instead of going from the point of dilation, instead of going from D to B, instead of going up 1 and over 3, we're going to do this new slope, this dilated slope. We're going to go positive 2, up 2, and negative 6. To the left 6. That's how we're getting B prime. You would then connect A to B, and then once we get C prime, you'd finish it off there. So how would we do C? Omar, what's the slope from our point of dilation to C? Jaylene, you want to take it? Perfect. You're going to go up 3 and then positive 2 or negative 2? Yeah. So then if we're going to dilate by 2, we're not going to go up 3. We're going to go. What operation is dilation? So we're not going to go up 3. Why 6? Good. So we're going to go up 6. And how much are we going over? Why 4? Perfect. So we're going to go over 4. So it comes over right there. Connect them and that's it. If holding it in your head is a little bit easier, okay, try that out. We're going to skip example 2. And I want to make sure we have this down. Because I'm still questioning, can we use this method? I see 5s and 4s. I know you can. And 2s and 3s, I want to make sure. So the front, right? The front is what you're working on, 1 through 3. Skip that last one. Use your notes, do 1 through 3. Wait, Alice, who are you allowed to work with? Your alpha partner. Where's your alpha partner today? Thank you. Thank you both. Show me number 1.
You know this is going on.
Can you show me, can you scroll?
Wait.
Moment.
And then you two, can you work on this one together? One of you writes, one of you talks.
You talking.
I'd rather write.
No.
Wow. You better explain it.
If somebody wants some assistance, talk to QJG. I know she
Okay,
has.
so you could do this, but let me just help you out. This is the okay.
Yeah, I mean.
So
You go to her. And that's
okay.
when you have
So
they have
we picked D because this is
Because
that is basically like the fake origin, so that's where we're starting. So now we're gonna rise and run to find what A is.
You're doing
No,
1
it's not,
through 3,
stupid.
1 through 3 on classwork 2-2. Don't worry
So the
about that on
measure
third dilation yet. Not yet. I want to make sure
of
you got this down first.
The measure of DA is 2/3. To the arrows.
it's negative, right?
Yeah, so that's -3. And then we're gonna times it by 2. And we will get
So from here, go over 1 up.
and we will get that. And now
Yeah, as long as you graph it. What comes back? You pointed dilation. Orientation.
No, I'm just writing it. Okay, so now find DB. It's just 1, 2. It's just a rise. So it's just 2, I'm guessing. Maria, when there's just a rise, right? When it's just a rise, and it's the same point. Like for that up there, you see D and then up B. So would it be 2 like that, or 2 over 0 or something? Or would it just be 2 over 2? I don't know.
If that's a skill factor 1, then D to B, that's skill factor 1.
So 2 over 1?
No.
I don't know.
You have
D to B, it goes up 2. That's a skill factor of 1. It's asking for a skill factor of 2. So what are you gonna do?
you go up again.
You go up 2 again.
Okay. So we're gonna do. So this was just a rise. We times that by 2, we get 4.
No, you plotted it wrong.
We're just doing it. We're gonna plot it.
No, I'm saying you plotted D wrong.
Say word.
It goes 1, 1, 2. 1, 1, 2. D is right there.
Why?
Look at the coordinates. X is 1, Y is 2. 1, 2. You did.
Sorry,
Sorry, guys.
you too.
Sorry, too.
Wait, what the fuck? But I like to show my work. So you're just gonna plot points. Okay, so since we're just plotting points and not showing our work, which I don't really suggest, and that would be A, B to C, B to C, oh shit.
They won't want me to the flag. No.
There you go. That's how you plot points. Mr. Here. Right there.
This is the same as saying 1.5, right? The scale factor of 1 is the arithmetic, right? That's the scale factor of 1.5. D to C is down 1 over. That's the scale factor of 1. But it's actually 8.5. I thought it was 9.5. So instead of going, let's say C was right here, right?
I keep
Going
doing
down
this.
to 1, so that's scale factor of 1. Okay, that's 5. It goes down 1 over 5.
Quick question. So because this is
Ooh, can you put that on? And then talk it out?
because this is 3 over 2, it's the same thing as saying 1.5.
Yeah.
So it's like that's still 1.
Well, you go half of that.
Yeah, so that's the same. Goes down 2 over 2, and then just 1, 1.
Yeah.
So
So D to B is 1, 2, 3, 4,
I would do
5,
it
6.
this way. I
Yeah.
think she's going a little fast. So from here, what's the slope? So we're gonna multiply.
Let me know when you get to 4.
We're gonna multiply the top one by that. So do it here. Just do it on the calculator. Yes, yes. So you're not gonna go just one. You're gonna go. So you go full and then a half. Instead of going 2, you're going. Instead of going 2, you're going. So from here. So instead of going over 2 and up 2, you're going to go. Yeah, so over 3 and up.
So that's
Assuming she has try out instead of going up 2 and over whatever. I would write out
oh, it is opposite.
whatever that is. And then 5 by. That's going to tell you the difference.
It's the opposite. And then from here.
We got like 5 minutes left. Miss Dietz and I are going to come around and check your front, your 1 through 3. Oh, that's a great point.
For what?
You can, while we're gonna come around and check, Cecilia just asked me, did I do this one wrong? She looked at her paper and she saw it didn't look right. When you do your dilation, what do you notice about corresponding sides?
That's what I can see.
What do you know about the corresponding sides? What do they look like?
Here, about that. A second. I don't get what you mean.
Is that new side ever going to intersect
No.
the original side?
No.
What's that called when two sides never touch?
Parallel.
That's how you'll know you've done it correct. Your new shape should look parallel to the original. And that was what Cecilia observed. So it doesn't look parallel. You have to learn the concept. You can practice. I know you. Take it home, work on it. Tomorrow we're going to practice. All we're going to do is just practice. We're not going to do any lesson. What's up? See you later.